So this is lesson 4.3, elementary algebra, operations with monomials. And go ahead and look at the top of page 249 when we get a definition of a monomial. It's a one-term expression that is either a constant or the product of a constant and one or more variables raised to a whole number exponents. Okay, that's a lot of mathematical jargon to say that when we have a monomial, it means there's basically no plus or minus sign between anything. So if I have something like 3x squared y z cubed, that would be a monomial. There's no addition or subtraction. This is making it negative, but it's not a subtraction. But if I have something like 3x squared plus 2y, I have two monomials because I've got a plus sign separating the two. Alright, so what we're going to do in this lesson is we are going to multiply monomials, and we'll start with the first example. They give us negative 3x squared, and they're going to multiply that by 4x. Is that a cubed? Yep, that's a cubed. Letter's so little I can't read it. Alright, so when you're multiplying monomials, a couple things to keep in mind. You're multiplying the numbers, negative 3 times 4, and you're multiplying the same letters. So x squared times x cubed is x to the 2 plus 3. Just remember, you add the exponents, and you're done. If I had a y here, there's nothing to multiply that y over here, so we just tag it on. It's just like we don't multiply it. We just put it on there. Alright, so let's look at the next example. 4 fifths x to the 5th y squared. And we're going to multiply that by 10 x cubed y. Okay, we can put that in parentheses if it helps. Doesn't have to be though. Alright, so again we're going to multiply the numbers. 10 times 4 fifths, so this is the same as 10 over 1. So 10 times 4 is 40 over 5. And then we've got this x and this x, and we're going to add those. 5 plus 3 is 8. And then we've got the y. Y squared times 1y, that gives me a y. 2 plus 1 is 3. Then I'm going to reduce that. 40 divided by 5 is 8. And we are done with that one. Now let's look at some division. If I have 15x cubed and I'm dividing that by 3x squared, the rules follow the same way. I do the numbers. 15 divided by 3 is 5, and then I do the variables. X cubed over x squared is the same as x to the 3 minus 2, which is 1, and we get our answer. In example 4, we have 39x squared y cubed, and we're going to put that over 3xy to the 5th. Okay, so let's divide that. 39 divided by 3 is 13. X squared over x is the same as x to the 2 minus 1, which we don't even need to put that 1 up there, but I've got it up there. And then y cubed over y to the 5th is y to the 3 minus 5. 3 minus 5 is negative 2, because 3 minus 5 is the same as 3 plus negative 5. Signs are different. We take the difference between the two and put the sign of the biggest number on there. We've been going over that lots and lots and lots, so hopefully that'll start coming a little bit quicker. And if we do not want a negative, if we do not want a negative exponent, we can put that y down here and make it a positive 2, because that negative just means it's in the wrong place. And so we get 13x over y squared. Okay, let's keep going. 25 a to the 5th b cubed, this is example 5, over 50 a squared b to the 7th. Okay, so we're going to divide. 20 divided by 50, or 25 over 50 is 1/2. And so and then this is a to the 5 minus 2 is 3. So notice what happened here is the variable goes on the top or bottom depending on which number is bigger. And this is another trick that you can do. I have 2 a's there, so I'm going to take 2 of them there, and that's left with 3 there. And that's where this one came from. Over here, I can do, again, the correct way of doing it is b to the 3 minus 7. Or I can go, well, I have 3 here, so let's get rid of those, and let's get rid of 3 of these, and that gives me a 4. Then I don't have to worry about having a negative exponent. I will always have a positive exponent, and it will always be in the correct place. And then we can take this, and we don't need to write that 1, and we can have an answer like that. Okay, so let's go and do another example. I'm going to take an example from the homework in 4.3. Let's look at number 22. 5x to the 5th, y to the 4th, z, and show you how that works as far as canceling. So like I say, there's many ways of canceling this or solving this. If you were to subtract the exponents, you would get, so let's just do it this way, 5 goes into 5 once, 5 goes into 36 times, so we just reduce 5 over 30. Then we have x to the 5 minus 3. So x to the 5 minus 3 would be 2. Y to the 4, y to the 4 minus 1 would be 3. And z to the 1st minus 2 would be z to the negative 1. And then this is in the wrong place, so we'd move it down. And so that would be your answer. Alright, so let's look at the other way of doing it, and some of you might find this easier, some of you might find it confusing. So we still have our 1 over 6. And I look over here and I have 3 of those, and I'm going to take 3 away from there, and that leaves me with an x squared up there because that's where I have left over. I've got 1 of these, I'm going to take 1 of these. I have 1 of these, I'm going to take 1 of these. And see what happened is I canceled this z completely up here, but I still have 1 down here, so I put it like that, and that ends up being my answer. So when you cancel like this, you don't have to add or subtract or anything like that. And then wherever you have one or more left over, like here I had 2 x's left over after I canceled 3 of them, because I canceled 3 here, so I canceled 3 here. I have 2 left over. I just leave it right there on top. And when I'm done, I will always end up with positive exponents, and I will end up with my variables in the right position. Okay, so the next video will be 4.3b.